Evet sevgili izleyicilerimiz, sırada çok değerli yeni bir konuşmacımız var. Llama2 uygulamalarını konuşacağız. Meta Policy yöneticisi ve yapay zeka tarafındaki yöneticilerimizden May Ryan bizimle. May, welcome to stage.
Hello, hi, nice to be here. Merhaba.
Merhaba. The stage is yours. Go on. You have 30 minutes just.
Great. I'm going to present. Okay. So hi everyone, thank you for the introduction and for having me here today. My name's Maeve Ryan. I am an AI policy manager in Meta's AI policy team. And I'm here today to talk to you about Llama2, which is the next generation of Meta's open source large language model. I'm going to start off with some broader context about AI and AI research at Meta, and then I'm going to talk to you about our approach to safety and responsibility when building Llama2 using some of the resources that we published alongside the models. So AI has been a critical technology at Meta since we launched the news feed over a decade ago. And we're continuing to make big investments in AI. This year, we're investing billions in compute capacity and infrastructure necessary for AI development. We use AI and machine learning across our family of apps to provide product experiences for our customers and for advertisers. So this is for things like feed ranking, community discovery, personalized ads, and content moderation. And AI is a really key part of our integrity system. So we use it for identifying illegal content and for things like understanding users' ages so that we can protect young people and ensure that they don't have access to adult features like Facebook dating. It would be virtually impossible for Meta to maintain the safety and integrity of our platforms effectively without AI. And we also invest heavily in AI research, including in generative AI. So I wanted to share a couple of fun tools that the teams at Meta have created. So in September 2022, we released Make a Video, which generates video from text prompts, and it can also create videos from images or take existing videos and create new ones that are similar. And there's a demo available online. And in August of this year, we announced Seamless M40, which is the first all-in-one multilingual, multimodal AI translation and transcription model. So this single model can perform speech-to-speech, speech-to-text, text-to-speech, and text-to-text translation for up to 100 languages, depending on the task. So this is a really major breakthrough in language translation models because it expands the coverage of languages and includes languages that historically have been less well served because they have a smaller digital footprint. And unlike other systems, which tend to divide the task of speech-to-speech translation into multiple stages and across multiple subsystems, Seamless M40 is a unified multilingual model that does that. So these are really remarkable tools, not just for enabling communication across different languages, but also for people being able to access information in their native language, which is obviously really key to people all around the world being able to make the most of the modern information environment. And it's not just Meta saying that these are great tools. Seamless M40 was named this week or maybe last week as one of Time Magazine's best inventions of 2023. And again, there is a demo. If you search Seamless M40, there is a demo online that you can play around with. So I'd encourage you to have a look at that. Obviously, language in the AI context is much more than translation, though. And this past year has been really major for Meta for our efforts on LLMs. And the one that I'm here to talk about today, Llama2, has been one of our most high-profile releases. And we released Llama2 in July for both research and commercial purposes. I'm going to speak today about the July release of this foundational LLM, but I just wanted to take this opportunity to mention that since we released this in July, we've also released Code Llama in August, which is built on top of Llama2. So go and check out the full Llama ecosystem on our website. But for now, I'm going to focus on Llama2. So yes, as I said, Llama2 is a foundational large language model, and it can be adapted to a variety of tasks. It is the successor to an earlier version of the model, Llama1, which was only available to researchers. And Llama2 is trained on 40% more data than Llama1, and it offers twice the context length, which enables more accuracy, more fluency, and more creativity in the model. And as I said, Llama2 is available not just to researchers, but also to businesses and developers to work with it and build products with it. And we've already seen some great use cases like personalized AI chatbots and businesses using Llama2 to create business support tools for their clients using their platforms. As of September 2023, we had more than 150,000 download requests for Llama2. So we expect to see lots more exciting use cases and applications in the future. So we released Llama2 in 3 sizes, 7 billion, 13 billion, and 70 billion parameters. All 3 versions were trained on the same number of tokens, which is a measure of the quantity of words in the training data, whereas the parameter size refers to the number of concepts the model has learned. And the larger models, so the 70 billion parameter models, require more resources to run, and they're also more sophisticated, whereas the smaller versions are cheaper and faster to operate. And for lots of use cases, the relatively lower sophistication won't impact its performance. So for lots of people, this is a great choice. But by releasing 3 different sizes, we're letting people choose what's the best use case for them. And as well as releasing the model in different sizes, we released pre-trained and fine-tuned versions of the model. Both versions, whether you're using a pre-trained or a fine-tuned version, require some further fine-tuning by the developer to make it suitable for their particular use case and safe. And that's what this flow here illustrates. Adapting the pre-trained model for human interaction requires a bit more AI expertise and quite significant compute power. So the pre-trained versions are more likely to be used, we expect, by researchers and by experts who have access to those resources. The fine-tuned versions that were fine-tuned by Meta are fine-tuned for single-turn or multi-turn chat-style conversations. And we did that by using over 1 million human annotations. And in that fine-tuning process, we also put certain safety and helpfulness features in place using techniques like reinforcement learning with human feedback and iterative red teaming to apply safety features to that fine-tuned version by Meta. And these Llama2 chat models, which is what we call those fine-tuned versions by Meta, perform better than most open models on a range of helpfulness and safety benchmarks. So for any version of the model, there's going to be additional fine-tuning necessary. And to help developers who are using Llama2 to do this, we produced a responsible use guide, which is a resource for developers to support them in their fine-tuning process. And I'm going to speak a bit more about that later on. Safety and responsibility is top priority at Meta throughout the process of building and releasing our models. And a key part of those efforts is publishing certain artifacts along with the model. So we produced a model card, a research paper, and that responsible use guide that I just mentioned, amongst other things. The model card is a single artifact that includes limitations of the model, fitness for purpose. They're very widely used in the AI research community as a way to be transparent about how you've developed your model and sharing relevant risks and limitations. The research paper is technically aimed at a more expert audience, but I think it's pretty readable, and this provides information on how we developed the model and the steps we took to improve performance and safety. The responsible use guide is purposefully written in very accessible language and is primarily aimed at developers who will be using Llama2 to build products. And it provides an overview of the responsible AI considerations that go into to developing generative AI tools and the different mitigation points that exist for LLM-powered products. And it includes instructions on fine-tuning, and that's what I'm going to talk about now. So within the responsible use guide, we include something called the responsible fine-tuning flow. And this is a 4-step process to support developers to fine-tune Llama2 for their use case. And it is guided at a high level by Meta's own responsible AI framework. So the first step is defining policies and mitigations. And we recommend that developers create a content policy based on the intended use and the audience for their product. And this content policy will define what kind of content you're going to allow your model to produce and any limitations you want to put in place on producing illegal or harmful content or certain things that you don't want your model to output. And establishing these policies is the first step because it will dictate the data that you need, your goals for safety fine-tuning, and the kinds of mitigation steps that you might use. And it's also used for labeling data in later stages. Step 2 is about preparing the data. So for developers developing downstream applications of LLMs, it's important to consider the suitability of your training data for your use case. So this section of the responsible use guide provides guidance on how to ensure that your data is sufficiently representative of the audience that you're targeting or your use case. So, for example, if you are developing an application not in English, ensuring that you have sufficiently representative data to create that kind of a product. And this is also the stage where you can examine for biases and understand those patterns so that you can mitigate their possible impacts. Step 3 is about the training the model. So the point at which the developer trains Llama2 on their data and fine-tunes it to their particular use case. And when we were fine-tuning Llama2, we did some safety fine-tuning, but we recommend, depending on the particular use case that a developer is developing the product for, that they do further safety fine-tuning. And we include different techniques that you might want to consider. So supervised fine-tuning is one example, which is using annotated data to train the model for safety and for helpfulness. Reinforcement learning with human feedback, which is a technique for creating this reward model using human feedback, which helps the model to learn what kinds of outputs are useful, accurate, and not offensive. And step 4 is about evaluating and improving performance. So this is about evaluating your fine-tuned model on a test set, measuring that performance for the task that you're developing the product for and against benchmarks. And And so at this stage, you'll analyze the strengths and weaknesses of the model based on those evaluation results, gather data, go back and improve the model based on that, that information, and keep iterating that process until you're satisfied with the model's performance. And the responsible use guide suggests for different evaluation techniques, benchmarking, manual evaluation, and red teaming. And as well as providing guidance for developers on how to fine-tune Llama 2, we also include a section on how to mitigate risks at different stages of the life cycle of a generative AI system. And we identify 3 different stages where risks can manifest and might have downstream consequences for the performance of your model and its safety. And there are steps that you can take earlier on in the process that will mitigate for downstream impacts. And you'll notice as I talk through this how it correlates to that responsible fine-tuning flow that I just talked about. So the training stage, challenges at the training stage, as I just mentioned, generally relate to the data on which the model is trained. So this is thinking about risks associated with bias, or perhaps the training data containing harmful or offensive content, which might shape the model's eventual outputs. And it's also important to think about privacy. So is there personal information present in the training data? User input risks are generally related to users potentially intentionally trying to make your product do something harmful. And again, there are issues also related to privacy. If users put sensitive information into the product, then it's important to be able to protect that. And at the output stage, the risks relate to generating harmful or offensive content, or even generating content that isn't offensive but is inaccurate. And you've probably heard of this referred to as hallucination, where models present something false as fact. So I'm going to talk through some of the steps that we took to mitigate for those different risks and challenges when we were developing Llama 2. So at the training stage, we conducted analyses on the data sets to assess for representativeness, using industry benchmarks that exist specifically for this purpose. So we analysed the data for representative of gender, for other different identifiers like race and ethnicity, nationality. And one observation that our teams made was that he pronouns were much more represented in the training data than she pronouns. And there was also a Western skew towards certain nationalities. I think the American was the nationality that was referred to. Nearly 70% of the references made that reference. So what that tells us is that the model might be learning less about context that mentions she pronouns, and might subsequently be more likely to generate he pronouns, or that skew towards American as a nationality might also be observed in the model outputs. And by conducting those kinds of analyses and understanding what the patterns are in the training data, you can develop mitigations to redress that balance. And also it's useful for guiding the appropriate model usage. We also evaluated for harmful content. And again, there are tools that exist to measure, for example, the prevalence of toxicity in a data set. So we tested a sample of our training data using a specially designed classifier for measuring for toxic language, and it produces a score for that sample of the documents. And that showed us that the data set contained a small amount of toxicity. And it's important to be aware of that kind of content, because that can inform how you mitigate for it. And sometimes that involves scrubbing some or all of that toxic data, so removing it. Sometimes you might choose to train the model to recognize that kind of content as being toxic, so that you can then put apply techniques to prevent that kind of toxic being output from your model. And that can actually produce a safer model by having a bit of that data within the data set. And then some of the techniques that we use to address the risks that can manifest at user input and output are safety fine-tuning and red teaming. So I've talked extensively about safety fine-tuning, but that is that process of training the model to identify and respond to prompts in a way that aligns with our safety guidelines. So you'll remember in the fine-tuning flow, we talked about having a content policy. So this safety fine-tuning process is training the model to abide by those policies and meet those expectations. And there are lots of different techniques that we use to do this, but the overarching aim is to train and incentivize the model to produce useful, accurate, non-harmful outputs. And the research paper goes into quite a lot of detail about that. So if you're interested in that, I'd suggest that you read that. Red teaming is an approach where teams try to make the model produce outputs that it shouldn't. So thinking about that user input risk of people intentionally trying to make your product do something you don't want it to, this is a way of testing for that during development. And we conducted red teaming exercises with internal and external teams to identify vulnerabilities and then fix them. So one of the things we didn't want Llama2 to do is to produce unqualified advice. So, for example, not advising people on how to make financial decisions. So we sought to mitigate that through safety fine-tuning. We took those steps. And then a red teamer tried to prompt the model to give them advice on investments, for example. And red teamers will try lots of different techniques, changing the prompt, trying different approaches to try and trick the model into giving that unqualified financial advice. If a red teamer identifies a way to be able to do that, then we can identify that as a vulnerability and go back and do further fine-tuning to prevent that from happening in the real world. They're not fail-safe techniques. There's still a risk that models will produce harmful or inaccurate responses. And so we also have incident reporting functionality that people can flag potential issues with the models. Finally, benchmarking and evaluations. As I said, this is about evaluating the model against industry benchmarks for truthfulness and usefulness and that kind of thing. So those are some of the steps that we took to build Llama2 responsibly. Hope it gives you a better understanding of the kinds of tools that are available and the kind of information that's contained within those resources that we produced alongside the models. And yeah, I'd really encourage all of you to go and have a look at the research paper and the responsible use guide. Finally, I just want to say a little bit about why we chose to open source Llama2. We did so because we think that an open approach is the best way for the AI community to build better, safer products and to accelerate innovation. It's good for Meta because a community of experts can improve our model by identifying potential vulnerabilities, which we can then fix, and also allows other people to identify, new applications. And we've done this before. We've learned from this before for one of our other language models, BlenderBot 2. Researchers found that they could trick the model into remembering misinformation, and we were able to act on that and go back and improve the model so that for BlenderBot 3, it was more resistant to this kind of vulnerability. And so that kind of improving the performance of the model is a huge benefit for Meta. And more generally, innovation in AI and a flourishing AI market and community is good for us, as it is for many, many other people. And we also want to put this technology into the hands of the wider AI community so that people can leverage these foundation models, which are really expensive to develop and train, and use them to build great products and services. You know, we want to help the AI community deliver on this promise of AI being able to improve people's lives. So on that note, I'm going to thank you all for your time, and yeah, please do go and have a look at the resources that I've discussed and the rest of the Llama ecosystem, so Llama2 and Code Llama, and you can find all of that on our website. Thank you.
Thanks for the great presentation, Miv. There are two questions from our audience for you. One of them from Mr. Cem Seçim. He asks you, do you have any Turkish support language?
In the Llama, so for Llama2, it was trained originally on English language. We have had, so that's what the training corpus is predominantly English, and we have had people who have then been able to fine-tune Llama2 for other languages, but it was not specifically trained comprehensively on Turkish. Seamless M40, the other model that I mentioned, does work for Turkish. I tried it this morning to see whether I'd be able to do my introduction. So yeah, Turkish is supported there, and I would really encourage you to go and have a go and play around with that and see how accurate and useful it is for Turkish, because one of these goals with these multimodal and multilingual models is to improve the performance for other languages. In terms of Llama2 and other foundation models, we know that from the wider AI community, improved language inclusivity and accessibility is a huge priority. And we expect that, you know, in the coming years, the wider AI community is going to be, heavily focused on increasing kind of accessibility of LLMs to other languages. And if you look at the research paper, I think, and I would have to double check this, I think it includes information about the quantity of different languages that are represented.
And the second question is from Kıvanç Değirmenci. The question is a little bit long. I will read it. Can you explain how you have discovered, addressed, and eliminated the potential bias and manipulation which you mentioned in the training dots and the model's outputs? What's your initial response?
So I'm going to be totally honest that for Llama2 specifically, I don't know off the top of my head in detail the specific techniques that were used. And again, that is included in the research paper. There's quite extensive information in there about that process. But what I will say is that addressing bias in Llama2 builds on years and years of research that Meta has been doing, both as part of our fundamental AI research team and also for our specific products on addressing bias and fairness issues. And it's something that we've invested in very heavily, is creating better data sets from the offset to address issues of bias and fairness. So, for example, we released a data set called Casual Conversations, which is specifically designed to create fairer, more performant data sets. But I would encourage you to go and have a look at the research paper for the kind of more technical details about the bias techniques that we applied for Llama2.
Okay, thank you very much, Miv, for the presentation and the answers. See you
Great.
again. Bye-bye.
Teşekkürler.